In this video, we're going to give TI-Nspire instructions for doing a t-test for the mean, for looking at a population mean. Okay, so we have here the level of dissolved oxygen, abbreviated DO, in a stream or river is an important indicator of the water's ability to support aquatic life. A researcher measures the DO level at 15 randomly chosen locations along a stream. Here are the results in milligrams per liter. So there are the 15 locations, and we want to know, do we have convincing evidence at the alpha equals 5% significance level that aquatic life in this stream is at risk? So I guess we need to find out, when is it at risk? Oh, sorry, right here. Dissolved oxygen level below 5 milligrams per liter puts aquatic life at risk. So we're testing, doing a test where mu is 5 milligrams per liter, and we're looking at a less than test. We want to find evidence. We're looking for evidence to support that aquatic life might be at risk. Mu is less than 5. So what I do on the Nspire to take care of this, once again, you do have to check conditions and so forth. And one of the conditions, well, we have randomly chosen locations, but we don't know anything about the population of dissolved oxygen levels in the stream. We don't know if it follows an approximately normal distribution. So we also have a fairly small sample size of 15. So we are going to have to look at a histogram or other graph of the data to check that third condition to see if we can use a t-model to do our significance test. So looking at the calculator here, I have a list where I have the DO level in here. I am going to first do my check to see if I can do a t-test. So I'm going to make a graph of the DO level. Okay, so don't really see a whole lot of anything that indicates any extreme outliers or skewness. I could make a histogram of this instead. Probably be better to make the bars a little closer together. And go to menu and zoom data. Okay, so looking at this, it looks like to me that the histogram of the data is fairly unimodal and symmetric, no obvious skew or outliers. Therefore, the conditions are met to use a t-test for this hypothesis test. So I am going to insert a calculator page and run the t-test now. So menu, statistics, stat tests, and a t-test. Now I've got data in a list, so that my input method would be data. And my null hypothesis value is 5, the list that my data is in. And then my alternate hypothesis is a less than hypothesis here. So notice here we have our t-test statistic. We see that we're about slightly less than 1 standard deviation below the mean of 5. We see degree of freedom is 14, our p-value of 18%. There's our x-bar, 4.77, standard deviation of the sample right here in n. So let's go back and take a look at how this p-value would be too high for us to reject the null hypothesis. So here's the values that we get. Let's go back and look at how these are used in the problem. So we go back to how this is used in the problem. Oh yes, I wanted to go ahead and show you. There's the histogram. Notice it's not exactly the same shape as mine, but it doesn't really matter as long as you kind of look at a reasonably shaped histogram with a reasonable number of bars in it. And this, I want to show you the normal probability plot too in just a minute. So here's our test statistic and how it's calculated. So x bar minus mu. Now if we look at what we had on the calculator, we have our x bar and our mu is 5. So we can use the values that are in here. So I'm going to use this x bar. I'm going to use this standard deviation. I'm going to use my n. I'm going to use the t. I can have, if I want to find my, want to label my degree of freedom here, all the information I need. So here is the 4.771, the x bar, here's mu, here's the standard deviation of the sample. So all of these values that I need to put in come from the test, and then I can find the test statistic. The p-value then is the area under the curve to the left of the test statistic in our t-model here. Remember, our t-model is very much like a standard normal model. It's just a slightly different shape than a normal model, but it's still centered at 0. And the t-statistic tells me how many standard deviations away from the mean I am instead of the z. Looking at our conclusion here, the book uses other technology, but I'm going to, it actually has me do this is actually doing a confidence interval too. So the conclusion, because the p-value 0.1816 is greater than our significance level of 0.05, we fail to reject null hypothesis. We don't have convincing evidence that the mean DO level, dissolved oxygen level, in the stream is less than 5 milligrams per liter. Notice we don't accept the null hypothesis, we just fail to reject it. So there's a quick explanation of doing your t-interval. Now, let's look at a couple other things that might happen. Oops, that's not what I meant to go to. I also wanted to look at a graph of a normal probability plot. So let's go back to our graph here. I guess it was this way. Oh, there's our graph. Yep. Sorry, back this way. I can also make a normal probability plot. So I go to plot type, normal probability plot. Now what we're looking for in a normal probability plot is we're looking to see, are the data, do the data follow a normal distribution? And basically we're looking for that to see if we can use the t-interval. The t-interval is still pretty close to that. So along here is the actual data values, and along here are the expected z-scores that we would get if it followed a normal model. Well, if those values lie on approximately on a line, then we know that we can, for the sake of our purposes, use a normal model. That we can say that the data it's plausible that the data came from a normally distributed population, or that the data in our sample is approximately unimodal and symmetric. So that's another way to check. And this one's a particularly good method if we have a small data set, because sometimes when you only have a very few values, it's hard to make a dot plot or a histogram that looks like much of anything. The other thing I wanted to show you was going to back to a calculator page, is sometimes then when we're doing a stat test, we are not given the original data. We may be given statistics about the data. So when I go to my t-test and I do stats, I just want to show you what you'd be putting in. You're still going to put in your null hypothesis value, but you're going to be putting in the standard or the mean standard deviation from the sample and the sample size instead. So you'd be putting in statistics about the sample instead of having the sample in a list in your calculator. And that's it.